Okay, for our very, very, very last lesson of the whole year, we are still talking about circles. And specifically, we are talking about inscribed angles. And then circumference and area. So those are our last three sort of topics here. And then we're home free, which makes me sad because there's so much more geometry, but this is all we have time for. Okay, so if you remember from Wednesday, I guess was the last time I saw you guys, we had a circle, and inside that circle, we talked about, obviously you have the center of the circle, and then we discussed if you were to create an angle so that its vertex was on the center of the circle. We had a special name for that. It was called a central angle, right? And then the fun fact about this was that every central angle is, if you, as it spreads out, it eventually hits the circle, right? So then you have this piece of the circle here. Let me get my highlighters ready. You have this piece of the circle in between A and B, and we refer to that as an arc. Miss Meal, hello. Are you late to school? Oh dear. I've already marked you absent, so let me see. I think I gotta send an email now. I don't think I can just change it. Oh, let me see. Yeah, I gotta send an email. Okay, pause for just a sec. Okay, so anywho, we were talking about this arc, and if you recall from our conversation before, if I told you that this angle was, I don't know, 120 degrees, let's say, then that was the exact same as the measure of the arc. Remember that? We can measure the parts of the circle in degrees just like we measure angles. So all the way around the circle is still 360, of course. So yeah, central angles and the arcs are exactly the same. You remember this? Is everybody with me? Because you're gonna need to know this. Yeah, you're good? So today, that's what we did Wednesday. Today, we are going to talk about a different type of angle whose vertex is not on the center, but it's on the edge of the circle. So check this out. If I went and I drew this, take a look at this cute little angle I just made right here. If you compare that orange angle to the central angle here, 120, do they look like they're the same measure, same size just by looking? No, they definitely don't look like they're the same. The orange one is clearly smaller than this central one, right? Can everybody agree with that? I have this one, it's pretty big. This one's definitely smaller. Anyone want to take a wild guess what you think its measure might be? The orange one? Yes. Yes, it is always going to be half of the measure of the arc that it's attached to, right? So central angles are always the same. And then if you have, this is what we call an inscribed angle. So inscribed angles just have their vertex on the edge of the circle, and they're just half of the arc that they touch. Isn't that neat? So the central angles stay the same, and then the inscribed get cut in half. So that one's 60. Okay, so let's write that definition down real quick and what we just said. So inscribed angles are angles whose vertex, I'm recording this, right? I think so. I sure hope so, because yeah, I am. Okay, good. All right, so angles whose vertex is on the circle's edge. And as we just learned, their measure is always going to be half of their arc.
So it's always going to be half of the external.
Got it. Always. So let's try some. I'll try and make them trickier and trickier. Okay, so there's my center point. We'll start with something easy. If this is 80 degrees, what's this? 40. That was too easy. Okay, we're going to step it up a notch. What if I did this? I know. I in my head I was like I was gonna do central angle and then I changed my mind mid-line. But you get the idea. There we go. All right. What if I told you this time? What if I did this instead? Oh wait. Is that what I meant to do? That's not what I meant to do. Ignore that. Ignore that. Sorry. Hold on. I'm all discombobulated. I meant to do this. Yes, that would be 100, right? So if I give you the angle, you got to double it to now get the arc. So the arc would be 100. Okay, let's make this more complicated. You ready? I knew you would be. Alex told me to do it and he missed it. She just said, what the? I was obsessed with smiley faces in 6th grade. Actually, I remember we did an art project where you made like your own little box and you got to decorate it with paper vine and smiley faces. How do I remember that? I don't know. Okay, so let's make this more difficult. What if you had a diameter and I did, let's say I wanted to know what the measure of this angle was if I told you that this arc right here was I don't know, 140. Go with that. So that blue arc is 140, and that's all I'm giving you. I would like you to find that angle in there. It is not 40. You're close. You got one more thing to do. Yeah. Something is 40, but it's not the thing you're looking for. Yes. So how are we getting there? This thing right here is a diameter. Okay, it runs through the center of the circle. So that means that this whole side has to be 180, right? Anytime I have a diameter, that whole arc, right? Remember the diameter cuts it into two semicircles? They're each 180. So if that's 140, that means that this little arc here is 40, but I wasn't looking for the measure of that arc. But if I have that arc, now I can find this angle by just taking half. So that little piece has got that missing, excuse me, that angle's got to be 20. Good. Okay, let's try another tricky one. Oh, come on, pen. Whatever, you get the idea that that's a circle. Let's see, how do I want to trick you this time? Oh, wait. This doesn't even have an inscribed angle. Oh, I'll do this. Oh, yeah, I'll do this. Oh, yes. Oh, my gosh. Okay.
So difficult.
So fun, you mean? This arc right there, I'll tell you is, let's go with 30. So if that's 30, I want you to find me this angle right here. Right there. That's what you're looking for. Did I give you enough information to find it? I sure did. Oh my gosh. Just start with whenever you have a problem like this and you don't know, you can't start at where you need to end. You have to start at what bit of information you're given and just start filling in other things that you know, right? Don't focus so much on where you need to end up. Just focus on, okay, I have an arc that's 30. So if I know that that's 30, I can find some other things. Anybody have another thing? Oh my gosh, this one problem encompasses so many of our different topics that we've talked about. Gosh, it's almost like this little tiny angle? Oh wait, what'd you say? Oh, this arc over here? Yes, that's true. Okay, hold on. Let me get another color. Hold on. So because we have a diameter right here, see what he's saying? This is a diameter. So that means that this whole arc, these two together, 30 and this one that I'm trying to put in green, that's got to be 180. That's not really showing up very well, is it? Can you tell that it's green? So this is 150. All right, now where do you want to go with that?
75.
75. This?
Yeah.
I'm gonna have to disagree with you on that one.
What the heck?
So because this, see, this angle that we're looking for, its arc isn't this thing in green, it would be this one over here, wouldn't it? This right here. So if you know that arc, you could take half, and I claim you do know that arc now. You can find this sort of dark. It is, yeah, for your final answer, the arc.
I finally answered.
Yes, this, because what's this arc gonna be?
30.
That arc is also 30, because look, you have another diameter right there. See that one? So you have another diameter.
Do like 30 and the one across from it.
Yes.
Why can't I have done that the whole time?
You could have. There's so many different things you could have done in this one problem. If that's 30, then this is a central angle here, right? So then this one's 30. And now you have vertical angles. If that's 30, this is 30, which means this arc is also 30. So you could have gotten it the way we kind of got there, going around this way. You could have used vertical angles. Now that you know that that's 30, yes, this is going to end up being 15. Another thing you could have done, oh my gosh, these are all radii, right? All of these, like from here to the center, here to the center, here to the center. So all of these are the same. Don't you have an isosceles triangle in here? Right? Do you see this really narrow triangle right here? You follow me? So you have this isosceles triangle. You know this angle right here. If that's 30, this one's 150. So what you're looking at, let me draw you this triangle. It's the same triangle, just drawn a bit bigger. If this is 150 and this is an isosceles triangle, remember the base angles are always the same? So you could do 180 minus 150, that's 30, split in half, 15 and 15. Do you see how exciting geometry can be if you know what you're doing? See? Do you believe that I get paid to do this every day? Me neither. How? Right? It's so fun. Yeah. Yes, after today's, you have one assignment left today. That's it. So you will know your final grade before you walk out this door.
Oh my God, that's okay. What if I don't finish it?
I mean, you have till Monday, but you'll finish it. We got plenty of time. Don't be. All right, so that's the bit about inscribed angles. Make sense? Everybody's all right with them? So then all we have left to talk about now are circumference and area. And I know you're familiar with them, but we're gonna get real familiar. So in the most school appropriate way. Okay, circumference and area. Can someone explain to me the difference between the two? Well, you're not wrong.
The area is like the whole inside.
Yeah. And what's the circumference?
Outside?
Yeah, it's the same thing as perimeter, just of a circle. So it's just the distance around that outside edge. So if you imagine, I know our track is not a circle, it's like an oval shape, but you could just imagine that our track was a circle. So if you went outside and you walked one lap around the track, you would have walked the circumference of that circle. All right, so circumference is distance.
But track is a circle, it's movable.
I know. I'm saying pretend it was a circle.
Oh, I was paying attention.
Yes. Distance around outside of a circle. So it's basically perimeter. Oh, sorry. Another thing, if you went outside and you actually did walk a lap, right? And someone said, oh, how far did you walk today? You would say, 1 mile or whatever. You don't say 1 mile squared. Thank you. Right? When you walk in distance, you just say, oh, I walked 3 miles today. I walked 15 feet, whatever it is. You just say the units as they are. You don't square them. That would be really weird. So that is an important thing to know, is that your units are just feet, meters, inches, miles, right? You don't change it. Now for area, let's imagine that you're the groundskeeper for Tantasco and you got to mow the lawn in the middle of, I guess in our case, it's our football field, right? So we don't actually mow that because it's fake, but that would be the area, right? Because you don't just mow the outside ring, you would have to mow everything on the inside. So that is area. So that will be the space inside circle. And this, yeah, now your units do change. Units are squared. So this is where we're going to start saying square feet, square meters, or meters squared. Doesn't matter, you can say it either way. Square miles, etc. Okay, and remember we talked about this. It's very easy to see it when you're talking about area of a rectangle because you're doing length times width. So remember we mentioned you're going to do like 3 meters times 5 meters. You're literally doing meters times meters. You get meters squared. Okay, so there's the difference between the two. And then we have the formula for each of the two, which actually encompasses the same 3 little pieces. It's just where you put them. You ready? So here's the formula for circumference. C equals 2 pi r. 2 times pi times the R stands for radius, of course. Area is the same. It's still a 2, it's still a pi, it's still an r, but we arrange it differently. It looks like this. Pi times the radius, and then instead of a 2, we make it squared. I suppose we can now. Izzy, would you like to do the honors?
What?
Turning off the lights?
Oh my God, yes, I would. I hate it right here. Hate it right. I love it.
No, that's better or worse.
So good.
It's better like that.
Like that? Okay. So I know you guys don't have to memorize formulas, but if you ever did, or it happens all the time, like kids can't remember which formula goes to which one. My cute little way to remember, you are pretty good about remembering that area is units squared. So that's the one that has the squared in its formula, in case you needed to know. So there it is. Now, one thing that I want to take a minute and talk about is pi. I know you know that pi is 3.14.
159.
Woo, look at you. Yes. But can anybody tell me where this number comes from? Like how, why this random number?
Pi?
Yes. Why 3.14159?
Oh, it's something to make numbers and they go on and go on and go on. That's
But
fine.
why that one? Why not 2.37?
Because
90.
people have spent time trying to calculate pi.
Just fight, like,
What is
Pi
it though?
pi.
I know you've known it since elementary school. I know you've known it's 3.14, but nobody ever seems to have a clue where it comes from.
And
What about it? You're right. It does derive from the circle, but what about it? What are we doing with the circle to get this number? Guess what? We're gonna find out right now. So here's what I need you to try and locate. If you can find for yourself some sort of cylindrical object. So you're really looking for something that has a circle. So look around. I'll find some things if you don't have something. Find something. So don't use my water bottle because
Oh my God. You pull your flashlight.
if you need something, come get from this pile here. You can take any of these things. What else do I have?
I got the
I don't see people getting up and getting a thing.
You want to take off the hands? No.
Oh my gosh, someone can use my black squirrel, just don't break it. Measuring the bottom. Do you know that black squirrels exist? I didn't know that.
Yeah, you didn't?
Yeah, I had no way, I had never seen one. I was at the Chicopee Walmart in the parking lot and I saw one run by
Yeah.
and I got so excited. I said to the girl in class, I'm like, do you see this? So I'd never seen one. She thought I was crazy.
Wait, seen what?
Black squirrel, so they're yeah, they're not common here, but there's like populations of them, and Chicopee happens to be
Yeah.
a high population.
Yeah, we'll stick with going. Yeah.
As a cat.
Yes. I
My
mean, I had 3 doors
Here's
for
my
squirrels,
stuff.
but I wanted to
Funny
take a
story.
bunch more.
My dad kept eating the squirrel. He got it where the squirrel would eat out of his hand.
Guys, I need you getting a cylindrical object, everybody. Come up and take one of mine. if
Be
you don't have one.
careful with your words.
Look at all these choices.
Look at me.
Spherical object.
Yeah.
My daughter was like, stop.
It's even more than was right.
Okay, I don't need to get any more of that. That was the reason my mom talked about that. And then
Come on, people, get your cylindrical objects if you don't have one. You can't.
Your mom's very old.
What's that?
You want to take it, that jar?
Where? My mom. I don't
And it might be a little.
Is it? Yeah.
And so, if I do my favorite, I'm
No!
it would work good.
It will not, I'm sorry.
Take my phone and my real.
Apple bucket.
What bucket?
I need the lights. for this,
Oh, I
sorry.
love scissors. Mom, it
I
is
did
scissors. I just today.
Sorry.
I love scissors, bro. I got
Alex.
Any of these items.
Oh. Wait, where's?
Broken. Did you like these, Bill? What?
Okay, I will do this tape. So here's what I need you to do. Hopefully your ruler, some of them, the numbers got kind of worn off. So you need to trade it for another ruler, that's fine. So I'm going to make a list of, here, I'm going to have to write.
No. Can I rewrite it, please?
Write it. You gotta, you gotta watch the board first.
It needs to be up like all, like, throughout the. summer.
21.
Just as like a reminder.
Okay, so here's what I need you to do. You're gonna take your cylindrical object and you're gonna take your rectangle. We are going to use centimeters.
All my
You're not giving your
We're
answer.
halfway there. We're
Yeah, feel free to
halfway
just swap it out.
there.
And make sure you get another bendy ruler.
Hey, you go.
So you need to measure, ladies and gentlemen, their circumference. So wrap your bendy ruler, be as accurate as you possibly can.
I can't see.
22 centimeters.
You're cool.
Centimeters?
Yes, centimeter, it's the millimeter one, but just tell me whatever the big number is.
I got 21.
I got 13. 13 and a half. I got 30.
Mine's
No,
12.
actually it is 13.
Mine's 12.
Yeah.
I want to do these.
Does that say dad?
No.
Yeah. What color you seeing dad? The second one. That's Lacey. I can't really
See?
I can't see.
You looked at me like that.
Okay. So everybody has their answer in centimeters, right?
Well,
Okay, so I'm gonna ask everybody, everybody's will obviously be different because we all have different circles. Lacey, what's your number?
24.
24? Okay, Ms. Musto?
25.
Yeah. Measure your circumference. I'll come back to you. See,
21.
Damien,
18.
Mary,
30.
Christina,
22.
yeah, Pam,
12.
12. Alexis. Tony. 35. And Izzy. 13. Okay. Oh, Kiana, did you get yours? 8. 8. All right, you ready? Now, I'm gonna ask you to find the diameter. So take your same cylindrical object and you're just gonna measure straight across for the diameter as best you can.
You start at 0.
Yes,
Honey, wait, I'm
straight across. So flip your
also
on bottom. Yeah. You can flip it over. It won't spill, right? Flip it
No, you
upside down.
don't, that ain't 5
So,
minutes.
yeah, so yeah, go straight across. You're gonna try and get the diameter as best as you possibly can. Triangle through the center. Mine's like perfectly done. All right, everybody has their diameter as best they can. The more accurate you are, the cooler this will be. They're not gonna be perfect because, No.
6 or 7.
but we'll be close. All right, Lacey, what do you got?
6.
6. You guys can give me decimals too. So if it's like 6.3, tell me 6.3. 6, you go with 6? Is most of 6 as well? Okay, Kiana. Measure straight across. You need the diameter. Alex D. 5. 5? Damien.
5.5.
5.5. Mary.
No, it was not, it was 4.5.
Christina.
2.5.
2.5. Fran. Centimeters.
Centimeter.
Make sure you're in centimeters still.
Yep.
Yeah.
Yes.
Yeah, but you said sorry.
Oh, centimeters.
2.5,
6.
something like that.
Already messed up.
Come on.
That sounds better. Hold on, I know I should have done lines, because I'm almost done. Okay, Ismail, I need you next. And what was yours? 2.5. 2.5. Alex, what's yours?
That sounds about right.
Tony, what do you got?
Bro, I can't do it.
11. And Izzy, what's yours?
4.
Kiana, did you get yours?
Oh my God, my hands.
Let's go for it.
2.5? Okay.
My hands so much.
No.
All right, you ready?
On the ground.
Here, guys.
So, here's what I want you to do now. You're gonna need a calculator.
I like that.
Okay.
I told you, I can measure this.
I want you to take your two numbers and you're going to divide them. So take your circumference and divide it by your diameter.
What's mine at?
It's up on the board.
Is it 13? What is this?
Yours is 13 divided by 6. I have to do mine.
I got 4.2.
Don't tell me yet.
45.
3.5.
3.5. Did we all have the same one?
You should. Yeah.
All right, Lacey, what do you get? Guys, I can't hear. Lacey, what you get? What is it?
0.6.
0.6?
Yeah.
Aren't you doing 24 divided by 6? Wouldn't that just be 4?
That should be
Right. Yeah.
4.
Oh.
Divided by
Ms. Muska, what you get?
It's 4.16.
That's fine. Kiana, what's
3.2.
3.2?
Wait, I don't know.
Who am I up to? Alex C, what's yours?
4.2.
So always do it twice.
Damien,
I have a repeating one.
go ahead.
Because we have 3.27.
Mary, what's yours?
3.53.
I'm sorry, I didn't.
3.53.
3.53.
No.
Guys, could you stop with the door noises? Justina, what'd you get?
I don't have it.
3.7? Yes, ma'am.
I have 0 tape.
3.3?
Electrical.
Bam.
No.
0
I
tape.
got, hold on. 4.8.
4.8. 2, right?
Yeah.
Tony, Izzy.
3.25.
Okay, so what I want you to look at this last column here. We all did circumference divided by diameter. Everybody had a different size circle. Look at what number all those numbers are awfully close to.
3.14.
Not just 3, but they're awfully close to 3.14159. So guess what? If we had proper measuring tools and we were doing it very accurately, every single circle divided by, if you take its circumference and divide it by its own diameter, it will come out to
Wait, so
3.1. So I think Tony's the winner. Yeah, so Tony gave us the most, and his was too big to even do with one ruler, right? Didn't it? Or did it? Did it fit? Yeah, so he did double, so gold star for Tony. If I had a prize, I would give it to you. Oh, I guess it'll be one share. Give me that. So yes, but that's wild, like they're all different circles. Yet if you take their circumference and divide it by the diameter, you will get 3.14159. Isn't that crazy? Now you know where pi comes from. Now, hopefully you see why it's such a big deal. Because every circle, no matter what, does this same thing. I know. All right, so we are almost done. Let's just try, you know what? Okay, let's collect the rulers.
Yeah.
Good idea. You've already one of my items, you could return it to the desk, that'd be great. Oh my God.
My hand is like so ready.
Casey, I was gonna see the other hand.
Oh,
Thank you, thank you.
I know.
Oh.
It's like a wrist check, bro.
Early for the.
All right.
Eight o'clock in the morning.
Oh,
Yeah,
Izzy, you
no,
can, Izzy, you can hit the lights again if you'd
Yeah.
like.
I'm so weird about this one, so early.
All right, so, we didn't get any of that on video, but they heard us, so. Oh, great, they heard us. Jeez,
Oh, so they just put tap, 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 tap.
Wait, who heard us?
the recording.
Oh. Yo, that's actually fun.
All right, so let's go ahead and try and find circumference and area for a couple of circles, and then we're done. So notice, by the way, before I do this, the only bit of information that you need is the radius. You can find both. That's it. So if you know the radius, or if you have enough information to find the radius, you've got everything. All right, let's check this out. We'll start off with a nice easy one. Let's say that's a 10, find the, well, let's do 10 meters. Find circumference and find area. Actually, let's do this one together because I want to make a point here too. So if I'm going to find the circumference, my radius is obviously 10, right? So I'm going to do 2 times pi times the radius, which is just 10. Now, if you ever, if you're reading the directions, they might say something like, leave your answer in terms of pi. Have you heard that phrase before? I'm sure you have. All that means is, hey, don't turn pi to 3.14. It's actually easier because there's less work that you have to do. All you have to do, it's also referred to as an exact answer. Once you turn pi into 3.14, now you've rounded it. So now everything's going to be off from then forward. So if I'm a manufacturer of something that has a round component, I'm leaving it as pi until the very end. Because I don't want to estimate now and then have all my calculations based off of an estimated number. Leave it as pi, and then you just estimate at your very last step. So if I just multiply the 2 and the 10 together, because remember multiplication is commutative, I can multiply in any order I want. So if I just write this as 20 pi, this is what we refer to as an exact answer. In terms of pi. So you'll hear that phrase, in terms of pi. That's what that is. Because I didn't round anything yet. I left it. Now, on your homework, and for most practical purposes, at the end, you know, I want a number. I'm not going to, you know, I don't know, the carpet store and saying I want 20 pi units of carpet. Like, that's not reasonable. So we do go ahead and take 20 and multiply by 3.14. And we'll see what we get. I get 62.8. So that's going to get me my rounded answer. I turned pi to 3.14 and I actually did the multiplication out. See how the exact answer has pi in it? I just leave it as pi, so it's 20 times pi. Now I just literally do 20 times the 3.14.
Oh, okay.
So now, because pi, remember, it never ends. So once you turn that into 3.14, now you're rounding your answer no matter what. Before I even round it on the screen, right? Because pi is not really 3.14. So we round it. Yeah, so this is our rounded answer. And don't forget our units are just going to stay meters, right? So we don't change anything for circumference. Now, when I go to find area for the same thing, it's nice and easy. I have pi times, now it's the radius squared. So my radius is 10, but I'm going to square it. So and the same thing happens here. I have an exact answer. That would be 100 pi, right? Because 10 squared is 100. So 100 pi, and I'd have meters squared. There's my exact. And then I could do the same thing when I, want to actually get my decimal answer. 100, oh, I don't have to do that. It's just 314, right? But now I'm rounding it because I rounded pi to 3.14. So I get 314 meters squared, and that is my rounded answer. So yes, on today's assignment, they are going to be asking you for rounded answers, but I need you to understand what leaving an answer in terms of pi means. It means literally leave pi in the answer. I wish I just phrased it that way instead. That's all it means, nothing scary. It's actually less work for you to do. But anyway, so there it is. So let me give you one more to try on your own. I'm gonna try and trick you on this one. You guys are too good for this. Let me give you the circle. Oh my gosh. Usually the circles get better as the lesson goes on. No, I'm just getting worse. It's the pen. I'm blaming it on the pen. Okay. Here, I'm giving you that this whole thing is 14. I would still like you to find circumference and area. Okay, so please find me the rounded answer for both of these. And let's stick with meters because it's easy. All right, what's your answer for the circumference? Are you sure?
I usually around it. So is it 80?
It's not either of those numbers.
Then what do you do?
You do 2 times pi times the radius.
What did Mrs. Sabia give you the 43?
Yes, 43.96.
I don't know, I'm still, what?
What's the radius, Alex? The radius of the circle.
14.
What?
Well, I'm confused.
Remember I said I was gonna try and trick you? I succeeded. That 14 is the whole diameter. That's the oldest trick in the book. So
Sorry, I'm so confused.
the radius is only 7, isn't it? Yeah, so you should have put in a 7 here for R, not the 14.
Okay. So, is the other software that we did before that, it's just.
Yeah, see this one, I only gave you the radius. See that? See the difference?
Yeah,
Yeah, so that's how I tried to trick you.
that's messed up.
Well, hey, I gave you a warning. So I'm doing 2 times pi times 7. 7 is actually my radius. So my exact answer, if I was looking for that, is just 14 pi. But I'm going to turn that into 3.14 and multiply together. So Mary is correct with a 43.96.
I got one. I got one.
You got the same answer for the area? Oh, okay.
153.8.
I don't know what the answer is, but that sounds right. Yes, that's right. Okay, so let's talk about how to get that. I have pi, and again, my radius is 7. So I got to put in 7 squared. So an exact answer would have been 49 pi if that's what I wanted, but I want to actually multiply those together. And that's how I land on 153.86. And what's my units? Yes, anytime you have an area, it's always meters squared, whatever your units are squared. You may, because we are now done. Guys, you finished everything that I need to teach you for GOCP.
Yo, let's go.
All right, so let me stop this.